Hey everyone, and welcome back to the channel. Today, we're diving into the mind-bending world of quantum computers. Now, I know what you're thinking, quantum sounds like something out of Star Trek. And yeah, you're not wrong. These machines are truly futuristic, harnessing the bizarre laws of quantum mechanics to solve problems that would bring even the mightiest supercomputer to its knees.
A new type of computer.
We're looking at a race.
Quantum computer, that it can perform a computation in seconds, what would take the world's fastest supercomputer.
A race between China, between IBM, Google, Microsoft, Honeywell.
Years, thousands of years to do that same calculation. And in the field, this is known as quantum supremacy, and it's a really important milestone.
All the big boys are in this race to create a workable,
Could soon change civilization as we know it.
operationally efficient quantum computer. Because the nation or company that does this will rule the world economy.
The journey of computers began centuries ago with simple tools like the abacus. In the 19th century, visionaries like Charles Babbage designed mechanical marvels like the difference engine, laying the groundwork for programmable machines. The 20th century saw the birth of electronic giants like ENIAC, colossal computers built with vacuum tubes. Transistors ushered in the miniaturization revolution, leading to the development of more compact and powerful machines. Integrated circuits further accelerated progress, paving the way for personal computers in the 1970s and 80s. The rise of the internet in the 90s connected the world and fueled explosive growth. Today, computers have shrunk to fit in our pockets, yet hold unimaginable power, constantly evolving and shaping our lives in profound ways. ENIAC, Electronic Numerical Integrator and Computer, was the first programmable, electronic, general-purpose digital computer, completed in 1945. But humans always want to build powerful computers that can process many complex problems in seconds. And here concept of supercomputer arise. Supercomputer history began in the 1950s with machines like the IBM NORC pushing the boundaries of computational power. The 1960s saw the emergence of true supercomputers, with the CDC 6600 in 1964 often credited as the first. Led by visionary engineer Seymour Cray, these early machines were highly specialized and powerful, tackling tasks like nuclear weapon simulations and weather forecasting. The 1970s brought vector processors and iconic machines like the Cray 1, further amplifying performance. The 1980s and 90s saw a shift towards parallelism, with thousands of processors joining forces in supercomputers from the US and Japan. Today, supercomputers are incredibly diverse, utilizing various architectures and distributed computing power to tackle ever more complex problems in science, medicine, engineering, and more. With advancements in technology, the future of supercomputing promises even greater leaps in processing power and the potential to tackle groundbreaking challenges. But the problem with these supercomputers is that they are very large classical computers, often with thousands of classical CPU and GPU cores capable of running very large calculations and advanced artificial intelligence. However, even supercomputers are binary code-based machines reliant on 20th century transistor technology. They struggle to solve certain kinds of problems. If a supercomputer gets stumped, that's probably because the big classical machine was asked to solve a problem with a high degree of complexity. When classical computers fail, it's often due to complexity. Complex problems are problems with lots of variables interacting in complicated ways. Modeling the behavior of individual atoms in a molecule is a complex problem because of all the different electrons interacting with one another. Identifying subtle patterns of fraud in financial transactions or new physics in a supercollider are also complex problems. There are some complex problems that we do not know how to solve with classical computers at any scale. But now quantum computer going to change everything. But the question is how? Well, quantum computer uses the principles of quantum mechanics to perform calculations. Unlike classical computers, which use bits either 0 or 1, quantum computers use qubits, which can be 0, 1, or both at the same time, a superposition state.
You can see that there is fantastic amount of information stored when you can look at all possible angles, not just up or down.
This allows them to perform certain calculations much faster than classical computers, especially for problems that involve a lot of possibilities, such as drug discovery, materials science, and financial modeling. Here are some of the key features of quantum computers. Qubits. Qubits are the basic unit of information in a quantum computer. They can be made from a variety of physical systems, such as electrons, photons, or ions. Superposition. Qubits can be in a superposition of states, which means that they can be 0, 1, or both at the same time. This allows quantum computers to explore many different possibilities simultaneously. Entanglement. Qubits can be entangled, which means that they are linked together in a way that their fates are intertwined. Even if they are separated by a large distance, the state of one qubit will instantly affect the state of the other. Quantum algorithms. To take advantage of the power of quantum computers, we need to develop new algorithms that are specifically designed for them. These algorithms can be very different from the algorithms that we use on classical computers. But from where quantum computer journey began, well, the story of quantum computers is a fascinating blend of theoretical brilliance, technological hurdles, and ever-expanding potential. It's a journey that began in the realm of physics and is now hurtling towards revolutionizing fields like medicine, materials science, and artificial intelligence. The groundwork for quantum computing was laid in the 1960s and 1970s with the development of quantum mechanics, the science governing the microscopic world. In 1980, Paul Benioff proposed the quantum Turing machine, a theoretical model for a computer that could harness the power of quantum phenomena. Richard Feynman, the legendary physicist, further ignited the field in 1981 by highlighting the limitations of classical computers in simulating quantum systems and suggesting the need for quantum computers. In October 2019, Google scientists announced they'd achieved quantum supremacy with a 53-qubit Sycamore processor, performing a calculation that would take a classical computer billions of years. But Google knew 70 qubits quantum processor that is 241 million times more powerful. According to the Google team, it would take the Frontier supercomputer merely 6.18 seconds to match a calculation from Google's 53-qubit computer. However, the same machine would take an astonishing 47.2 years to match a computation executed by Google's latest 70-qubit device.
It can perform a computation in seconds, what would take the world's fastest supercomputer years, thousands of years, to do that same calculation. And in the field, this is known as quantum supremacy, and it's a really important milestone.
Today, the race is on to achieve quantum advantage, the point where quantum computers can outperform classical computers on specific tasks. Governments, tech giants, and startups are pouring resources into research and development, with companies like IBM, Microsoft, and Amazon offering cloud-based access to quantum computers. But Google is only one to achieve 53-qubit quantum computer. Quantum computers are still in their early stages of development. Building and maintaining these machines is incredibly complex. Keeping qubits stable is like balancing a feather on a hurricane. But researchers are making huge strides, and quantum computers are slowly moving from science fiction to reality. So, what do you think? Are quantum computers the future? What questions do you have about this strange and fascinating technology? Let's chat in the comments and explore this together. Thanks for joining me on this journey into the quantum world. Remember, the future is uncertain, but with quantum computers, the possibilities are truly limitless. Keep learning, keep questioning. If this video add value in your life, support us, like this video, subscribe my channel. See you next time.